It's learning.
Okay, so here we go. So a physicist knows the velocity of a particle, might wish to know its position at a given time. An engineer who can measure the variable rate at which water is leaking from a tank might want to know the amount of water leaked over a certain period of time. A biologist who knows the rate at which a bacteria population is increasing might want to deduce what size the population will be at some further time. So the idea is you have a rate of change, and you want to find the function that is the rate of change of. The big thing you need to first lock into is that if we have a function f and we're trying to find the function whose derivative is lowercase f, it's starting from capital F. So what this means is f prime of x, capital F, is going to be little f of x. That's the first just notation you need to know. That's the first notation. So you can think about this. Contained in, exactly. This means contained in, absolutely. What's the antiderivative of x squared? So the derivative of what is x squared? 1/3 x cubed. What's the antiderivative of g of x equals x to the 4th? 1/5 x to the 5th.
Yeah.
Are those the only ones?
No.
Give me another one.
1/5 x to the 5th plus 20.
20. Any constant. Any constant. The derivative of a constant is 0, so you can tack on any constant you want. You have to remember to write that in, and in many cases, it doesn't matter because if you are subtracting c from c, what do you end up with? 0. It is quite, in many cases, it's going to be quite frequently the case that you will be obliterating the constant, so it's not really that important for the final answer. That being said, you need to remember it is there because will it be sometimes very important?
Yeah.
For example, visually, I could give you something like this. I could say, here is the function f. What's the antiderivative? That could be, let's say that's y equals x squared. What's the antiderivative of that?
It could be like 200.
There's many of them, right? Could it be this?
Mm-hmm.
But then you can take this and do anything you want. You can move it up or down. You can move it up or down. So you have to just remember that it's not unique. It is not unique. Try these. If you can't get it, just skip it and we'll come back to it. And I did give you a hint on it. Just be careful. Try this. Yeah, go ahead. What is it? The derivative of what is sine? Yes. Negative cosine x plus c. You have to say plus c. You have to, because look, most general.
Okay.
What about the next one? Can anybody nail this one for me? Maddie, what is it?
1 over n plus 1 multiplied by x to the n plus 1.
Try differentiating that and see what happens. Careful. Chris, you want to help with this one? You guys know the answer to this because you've already actually been told it.
Wait, that was first.
I'm talking about B, yeah. I'm talking about B.
Is it
Oh,
B.
ln plus c?
Oh, did I say C? I'm sorry.
said C.
I'm sorry. Anybody have B? Anybody have B? What is it?
Is it ln x plus c?
Yes.
Yeah.
Yes, it is.
Oh. This took me just now to see that.
Yeah, right?
I have it.
You're asking the derivative of what is 1 over x? The derivative of what is 1 over x? ln x. We already proved that. You need to know that. The thing is, you're tempted to do this, right? You're like x to the negative 1, right? So, but what happens if you add 1 to negative 1? It doesn't work, right? What's x to the 0? Yeah, problems, right? But you already know the answer to that. You have to remember the things you've learned before, and you know tons of derivatives, right? Therefore, you know tons of integrals. You know tons of them. What are the 6 that you probably... No, sorry. What are the 6 that you absolutely need to know that I can pretty much guarantee?
Or trig function.
Trig?
No, not be more specific.
Trig functions, natural log functions.
No.
Okay.
The derivatives of what function specifically do you need to know cold?
Sine, cosine, tangent.
Those are like
natural
basic
log.
vowels. Those are like walking down the street. But they're the other ones that'll get hit by a bus if you don't know. The derivatives of inverse trig functions. You need to know those 6 cold. You need to be able to just do them without thought. And if you don't know that right now, it will be very painful for you because those will come up all the time. And the thing is, if you know that the derivative of an inverse trig function is like 1 over 1 plus x squared, you're going to do questions where you're going to do some creative algebra, and then it's going to ask you, what is the antiderivative of 1 over 1 plus x squared dx? You will have to know just off the top of your head that that's the derivative of
Inverse tangent.
inverse tangent. And if you don't know that, you cannot derive it on the test. You will waste tons of time trying to derive that. What about the third one right here? So, Maddie, you had this one, right?
1 over n plus 1 multiplied by x to the n.
Yeah, plus c.
C.
Absolutely right. Correct. The n plus 1 nukes comes out to 1, goes down to n. Can someone tell me how I should not try to do this one? Can someone tell me how I should try not to do this one?
I would assume that you're gonna say quotient rule.
Something about the quotient rule, exactly
Yeah.
right. If I asked you to take the derivative of it, hold on. If I asked you to take the derivative of this, could you use the quotient rule?
Yes.
What have I told you about using the quotient rule?
Don't.
Try not to. Like sometimes you really have to, but in this case, you don't have to because what can you do? Simplify.
Divide by.
Yes, that's the whole point. My point is, you might think to yourself, I need to use the quotient rule to differentiate this. What about undoing the quotient rule? Will we learn how to undo the quotient rule?
Yeah.
Yeah, we will. We're going to learn how to undo the power product chain, those rules. It gets a little complicated, but in this case, you don't need to do that because just simplify first. Always look to simplify. It's going to be 2x to the fourth minus x to the what power?
Negative.
But it is to the fifth.
To the fourth. To the what? Negative what?
Negative 1/2.
Negative 1/2. So therefore, f of x is going to be what? 2 of 5, x to the fifth, right?
Yep. Plus 1/2.
Plus, really?
Yeah.
You sure?
Yeah, sure.
Why?
Because the negatives
there's a
cancel.
negative 1/2. So then.
Yeah, but when we take the derivative, it needs to be negative, right?
Be negative, it's gonna end up
It's got to be negative what?
negative 1/2 x to the
1/2? You sure?
Yeah. Actually.
Really? What power? Okay, what when you add 1 to negative half, what do you get?
It's got to be 1/2.
1/2. So you're dropping a half to the front. So the 1/2 has to cancel with whatever's in front to not 2x to the 1/2 plus c. Because when you take the derivative of that, 1/2 drops to the front. What's 1/2 times 2? 1. You need it to be negative. It has to be negative, right? So the negative has to be out there. You don't create the negative by subtracting 1. The negative has to be there. 1/2 minus 1 becomes what? Negative 1/2. When you start this, guys, this will be, you're going to be able to do this in your sleep, okay? You're going to be able to do this in your sleep. Anti-differentiating polynomials or anything like polynomials, you're going to do it like that. What you focus in on, if you're going to do the math in your head, focus on the power first. Add 1 to the existing power and then figure out what you need to put in front of it to get rid of dropping that power to the front. If it's going to be 2/5 up there, it's 5, just do it piece by piece in your head. Do it piece by piece. So the lessons are, okay, this one says, find f. So in this case, find f if the second derivative is this, and the original function evaluated at 0 is 4, and the original function evaluated at 1 is 1. Give that a try. See how far you can get in setting that up. See how far you can get in setting that up. If you anti-differentiate the second derivative, what do you get?
The derivative.
The first derivative. And if you anti-differentiate the first derivative, what do you get? The original function. Give that a try. See how far you can get. So what do you think the common mistakes are in a question like this?
Dropping things down.
Not putting
Yeah,
the
drop-
x in front of the constant.
Not putting x in front of the constant, like simple stuff.
Yeah.
Remember
And
easy
then
stuff.
just go for it.
Boom, yeah, just
It's
folds.
that easy.
It's-
If
it's-
people
it's
did
not-
all the little things in sports, nobody would.
Okay. So what should you do to 14 first if you're going to deal with it? What are you going to do first? What are you going to do first? Turn it into a tangent. I heard that as a noun, but what are you going to do? Simplify. So what do you turn it into? It's sine theta times what? Sine theta over?
Cosine theta.
Okay, so that's equal to...
Oh.
No. 1 over what?
You had it right.
I had it right?
Yeah.
Cosine is... So
It's
what?
cosine times sine over cosine.
Cosine time? No, it's 1
1
over
over
cosine. Oh, look at that. Good. Times sine theta over... equals what? What's 1 over cosine? Secant theta. And what's sine over cosine? Tan theta. Okay, so you're trying to... the derivative of what is that?
Secant theta.
So therefore, h of theta is
Secant theta.
Oh.
secant theta plus c.
There's a way, roundabout way to do that.
Yeah, sure. But here's the thing. You have no clever tricks yet for anti-differentiating. None. So what do you have in your arsenal? Simplify and then see it. The only rule that you know how to undo is the power rule right now. That's it. So are you trying to undo a quotient rule? No. Not at all. Not at all. You need to. That's why you need to know these derivatives cold. You need to know the derivative secant is secant tan. Okay. So you want to see 15 as well? Okay, we can do 15. That's fine. So that was 14. For 15, the first part of it, f of x. What's the antiderivative of 2x? X squared. X squared. Now you're trying to do the integral, and I'll just use the symbol even though you haven't seen it yet. You're trying to do this. 1 minus x squared to the what? I'm using new notation. Don't worry about it, but you're trying to find the integral of that. Okay, and you have a plus c out here. Great. That 5 just is along for the ride. Do you agree?
Yeah.
Yeah.
So what are you really trying to find? You're trying to do the integral of 1 minus x to the x squared, right? To the negative 1/2 dx. Don't worry about this notation. I'm showing you it now, but you're going to get to it. Let's rewrite it a little bit. Can someone tell me what thing makes this a little bit more complicated to undo? The thing inside the parentheses. It's a problem, right? What might you think the answer is? If you did this, I might say it's like 1 minus x squared to the what? To the 1/2? But then what would you have to put out front? What? 10. Why 10? To get 5. But if you take the derivative of this, what do you get? You get 5 times 1 minus x squared to the negative 1/2 times what?
Plus 2.
Times what?
2x.
Times negative 2x, right?
Yeah.
Same thing with negative 10x times 1 minus x squared to the... So you almost have it, right? Almost.
Almost.
Almost, but there's this problem where so you're like, okay, so maybe I just put an x right here, right? To get rid of that x. But what happens now, if I differentiate that, what rule do I have to use?
Product.
The product rule. And does that make it worse?
Yeah.
No, yes.
Yeah. So as you try to like take care of the problems you're creating, what starts happening? More problems come up. Okay, so let's go back and look at this. Let's rewrite this a little bit. What does negative 1/2 to the negative 1/2 power mean? 1 over. So it's 1 over what? The square root of 1 minus x squared dx. Okay, so I want you to stare at that.